Good morning, ladies and gentlemen. Thank you for being here to delve into the exciting realm of UAV assisted millimeter wave communication and its intersection with cutting edge machine learning techniques. Today, I am honored to present systematic literature review on the machine learning techniques for UAV assisted millimeter wave communication that not only bridges the gap between UAV communications and machine learning, but also distills the collective wisdom of the research community. Our review sheds light into the various techniques, approaches, and trends that have emerged and offers a roadmap for future endeavors in the dynamic field. My paper ID is 3547, track 7, RF microwaves, wireless, and optical communication. Authors are Sugesh Amas, myself, G. Vairavel, and Dr. K.T. Madhavan. Introduction. 5G communication is viewed as a good potential paradigm to support enhanced mobile broadband, ultra reliable low latency communication, massive machine type communication. The application of machine learning solutions in UAV assisted 5G communication can bring significant benefits to 5G and beyond 5G communication. There is little elementary, secondary, and tertiary study on machine learning applications in UAV assisted 5G communication. Owing to the dynamicity of UAV position and altitude, low altitude platforms UAVs are extensively used as aerial base stations and for communication relying in terrestrial communications and high traffic such as stadiums and crowded places. The technical challenges in the use of UAVs instead of terrestrial networks include flight time, optimal UAV placement and trajectory optimization, channel acquisition and reconstruction, and resource allocation. Since energy efficiency is of major concern in UAV aerial base station, the introduction of machine learning techniques is very essential to overcome the beam selection and energy efficient optimization issues. Although there are many research works for UAV assisted 5G millimeter wave communication, the use of machine learning for beamforming in UAV assisted 5G communication is still in the initial stage. So in this article, we deliver a systematic study of all important research activities in which machine learning techniques and algorithms used in UAV assisted 5G millimeter wave communication, existing surveys and tutorials. In light of the advantages in UAV assisted millimeter wave communication, recently there are numerous research works are progressing. These activities also include number of surveys and tutorials on UAV communications. Even though these surveys discuss relevant issues in UAV assisted communication, there are many limits. In the reference paper indexed as 9, Sayao and others investigated the hierarchical beamforming codebook structure along with the codebook design via subarray technique for fast beamforming training and tracking. In most of the reviewed surveys, the channel modeling and the channel characteristics were discussed. The areas in UAV assisted millimeter wave communication explored and the challenges identified in survey papers include interference, channel modeling, routing, seamless handover, and UAV placement. From the review of survey papers, it is evident that there are no or only few works are concentrated in the application of machine learning in UAV assisted millimeter wave communication. To fulfill the gap in the aforementioned area, we are focusing on the application of machine learning in the beamforming, three-dimensional deployment, and UAV trajectory planning in the application of UAV in millimeter wave communication. So the methodology. A systematic evaluation procedure was explained according to the guiding principle written by Mr. K. Kitchenham, index list 24 in our paper, and the four research inquiries were created. The latter three being derived from the primary question. The research inquiries have the subsequent aims, which is listed in table 2, to characterize the main machine learning algorithm and the frameworks applied in 5G UAV assisted wireless communication. Second one, identify the main UAV based communication where these algorithms frameworks are applied. The third one, define the key types of application of these algorithms in UAV assisted wireless communication and describe the key results and benefits of applying these algorithms in UAV assisted wireless communication. About the addition and elimination criteria, those main studies that presented machine learning methods and applications in UAV assisted wireless communication with qualitative and quantitative main studies were considered qualified. The articles published in English throughout the period 2018 to 2022 were taken into consideration. Main purpose that did not dispose the focal objective of this work were excluded. Regarding the research repositories considered, Hindavi, IEEE Explorer, Springer Link, MDPI, Google Scholar, and Elsevier Science Direct were chosen. The article assortment process was divided according to the phases stated in figure 2, which includes examination in study repositories, elimination of identical studies, omission of studies by heading, omission of studies based on abstract, and application of quality standards. The research procedure in uh, the search procedure in the sources used in the descriptors to generate the exploration thread are as follows: UAV assisted 5G communication and machine learning, UAV and wireless communication and machine learning, 5G and machine learning and UAV, reinforcement learning and UAV, deep learning and UAV, and 5G, artificial intelligence and UAV communication. So the results. The research question, the first one was, what are the major machine learning algorithms used in UAV-enabled wireless communication? This investigation query is characterizing the major machine learning algorithms or frameworks applied in UAV-assisted 5G communication. Incorporating machine learning techniques into 5G wireless networks can leverage intelligence to solve various problems, which assures time complexity reduction and unique performance gains in terms of energy efficiency and memory usage. Machine learning is the essential technology that enables supervisory capabilities to achieve the proper deployment and trajectory of UAVs. The main areas in UAV assisted wireless communication where machine learning is applied includes UAV swarm communication, resource allocation, trajectory prediction, energy optimization, target detection, etc. The reinforcement learning and unsupervised learning are the main two machine learning categories that are applied in UAV assisted wireless communication. K-means algorithm, Q-learning, SALP algorithm, deep Q network, liquid state machine, and convolutional neural networks are a few learning algorithms and frameworks applied to tackle the problems in wireless communication areas in the UAV scenario. The second research question that we created was, what are the UAV assisted 5G communication process in which machine learning algorithms are functional? So the first process where the machine learning uh, algorithms are functional is machine learning in beamforming. Various applications of machine learning tools in UAV RAN are presented here, which includes radio resource allocation, dynamic placement of UAVs, choice of the type of UAV, selection of number of UAVs acting as base station, positioning of UAVs as base station, and trajectory prediction. Although there are many research works for UAV assisted 5G millimeter wave communication, the use of machine learning for beamforming in UAV assisted 5G network is still in initial stage. The second one process is machine learning in resource allocation. In UAV-based millimeter wave communication, the limited resources are shared between mobile UAV base stations and ground communication networks. To attain the optimum performance of the network in terms of network users and throughput, it is necessary to design an efficient system for resource allocation. Since the UAVs are battery powered with limited lifetime, the key factors in resource allocation are time slot allocation, bandwidth, power, and user association. The third process is machine learning in dynamic placement of the UAV. To support ground communication networks, the main mechanism of UAV communication are dynamic deployment of UAVs, line of sight links, and UAV swarm networks. In dynamic UAV deployment, UAVs can be deployed dynamically in a timely changing environment compared to fixed organization, making them more strong to be used in actual applications. The fourth process is machine learning in trajectory prediction. In SWAM networks or UAV assisted communication networks, it is very much important to predict the location in the next movement of the participating UAVs for seamless and reliable communication. The third research question or research inquiry that we have created is, what are the major application categories of machine learning algorithms or frameworks in UAV assisted 5G communication? This investigation question aims to describe the major classes of application of machine learning algorithms in UAV aided 5G communication. In UAV swarm network, the commonly used machine learning algorithm are reinforcement learning, Q learning algorithm, and GAK means algorithm. The table 3 depicts application classes of machine learning algorithms. The fourth question was, what are the major outcomes accomplished of applying machine learning algorithms or frameworks in UAV assisted 5G communication? So the outcomes are as follows. The research question 1. A. What are the major machine learning algorithms or frameworks used in UAV enabled wireless communication? Answer is, the major machine learning algorithms or framework applied in UAV assisted wireless communication are Q learning, MARL, K means AMSSA, genetic algorithm, SVM, SVR, ANN, LSM, cross entropy algorithm, DL algorithm, and reinforcement learning algorithm. There is a second outcome is for the research question. What are the UAV assisted 5G communication process in which machine learning algorithms are functional? Answer is, the major activities are beamforming, resource allocation, 3D deployment, and trajectory planning. The outcome of research question 3 was, the main applications of machine learning algorithm in UAV assisted 5G communication are in device to device communication, multi UAV communication, trajectory planning, channel modeling, resource allocation, smart farming, and flying mobile edge computing. And the outcome 4 is the major results machine learning algorithm application in UAV assisted 5G communication are improved energy efficiency, less time complexity, improved accuracy in prediction, and efficient resource allocation. So, after doing the systematic literature survey, we have identified few open issues that is need to be addressed. The first one is multi-UAV system requires optimum beamwidth for better interference performance and is an open challenge in UAV assisted 5G millimeter wave communication. Second one, in the multi-UAV environment, the computational complexity and energy consumption needed to be addressed. Movement of UAV has not been pointed based on the UAV user's mobility in most present investigation articles, which mostly focus on the two-dimensional placement of multiple UAV or the motion of single UAV while ground users remain stationary. Research on the three-dimensional placement of mobile multiple UAV considering ground user mobility is another open issue. In UAV swarm communication, the performance of the front-runner UAV has become the tailback to enhance the performance of the whole UAV cluster, which necessitates more research considerations. In most of the trajectory prediction algorithms, it considers only two-dimensional movement of UAV. Hence, there is a scope for research in trajectory prediction of UAV considering three-dimensional movement. So these are the open issues that we have identified, and the listed are the references which we have referred and scrutinized after doing the systematic literature survey. Thank you.